All right, here in this video, we want to look at an application dealing with our equation. And the example we have here is you purchase an all-terrain vehicle for $8,000. The depreciated value, y, after t years is given by the equation y equals 8,000 minus 900t, where t is between 0 and 6. 0 is less or equal to t is less or equal to 6, so that tells us t, the time, is between 0 years and 6 years. And they want us to sketch the graph of the equation. Now, of course, we could certainly make a little table, and here our t is kind of our x value, so we could make t as our x and then y, and we could certainly pick a value for t such as 0, and we could plug that in. We could pick t equals 1 and plug that into the equation, and we could find the graph of the equation that way. Now, I want to take a little bit of time and look at how we can use our graphing calculator. And this is a TI-84, and of course, if you have some other TI like a TI-83, it's going to be very similar to this. So if we go here to y equals and type in the equation, y equals 8,000 minus 900t. Now, you don't have to worry about putting the variable t here. I'm just going to hit the variable button here with x, so it's 900x. And I usually like to start with hitting zoom standard, which is number 6. And if we look at the graph, let me just copy this here. If we look at the graph here, notice we have a vertical line. So we would expect a straight line based on the equation 8,000 minus 900t, but do we think this is a very good representation of the graph of this particular equation? Well, if you notice, our numbers are much bigger here. We have 8,000 minus 900t, and our window, because we went to standard, is negative 10 to 10 on the x and the y-axis. So let's see how we can change the viewing window to get a better representation of this particular graph. What do you think we would want to go to? Well, if we look closely, they tell us that t right here is between 0 and 6. Well, that's the x-axis. So if we go to our calculator, we can go to the window. Our minimum x would be 0. So that's when we initially purchased the ATV. And then we want to look at it for the next 6 years. So we could type in 6. And I'm actually going to go one further than that. I'm going to type in 7 just so that it maybe shows up a little bit better on the screen. And I'm going to leave the scale at 1. And now we need to figure out what is the minimum y value and the maximum y value. Well, what does y represent? Y is representing the depreciated value. Okay, so if we start out with the ATV at $8,000, so that would be the maximum, because from that point on the value is going to decrease, and if it decreases, the lowest it could decrease to would be 0. So we could make the minimum 0, and the maximum we could certainly type in as 8,000. So now if we look at the graph, we get a much better representation here. So if we take and copy this, notice the difference here, how much better this looks, because now our window, we went from 0 to 7 and then from 0 up to 8,000. And because this is representing a depreciation in value, the value starts up here at 8,000, it's going to make sense that it's going to have this decline over time. So here we're looking over the period. They wanted us to look at the period over from here, which would be 6 years, and that's down to this point. So we can see the decline here. Now, how much do we remember here about the equation? If we have y equals, and I'm going to rewrite this as y equals negative 900t plus 8,000. Now, doesn't this look a lot like y equals mx plus b? And some of you are familiar with this. If not, we'll talk a little bit more about this. If we notice here, if you can recall this negative 900t, that gives us a slope of a negative 900. And we would think of that as being over 1, because any whole number we can write over 1. So negative 900 over 1. And that is looking at the change in our y over the change in our x. So what that says is if we start up here at the top at $8,000 and we go over here to 1 year, we go over and then down, then it's going to, this is over 1 and then down 900. So that means the value of this ATV has decreased by $900 for the first year. And if we go over another year and down, it's going to decrease another $900. So after 2 years, it will have decreased by $1,800. And what we're saying is every year, based on this negative 900, is that we're going to decrease the value of the ATV by $900 every year. Okay, now the main reason I would look at using the calculator for this example is I want you to realize how important it is to make sure that you have the correct viewing window when you're looking at your graph, because over here when we had negative 10 to 10 for both the x and the y, it looked like we certainly just had a vertical line, when in reality it should have been a sloped line here going down, because we were talking about a depreciated value. So make sure you read your word problems carefully and see if your graph makes sense. And again, because the numbers are so large, we had to have a larger viewing window. Okay, now if they didn't give you any information here, one thing you can always do to help determine the size of your window, you could go to your table. So if you hit second function and graph, this takes you to your table here. And I'm just going to delete these numbers out that's already here. And you could just randomly pick some values for x and say, well, if I let x be 0, then the y value is 8,000. What happens if I let x be, say, 10? You get a y value of a negative 1,000. So that kind of gives you an idea that when you pick relatively small values for x, you're going to get pretty large y values. So if you notice here, looks like your y value here from 0 to 10, your y value is going from 8,000 down to a negative 1,000. So that gives you a little bit of an idea how you could go into and adjust your window. Now for our example, because we were only looking over the time from 0 to 6, we went from 0 to 7. If we wanted to look at it over a longer period of time, then we would continue that out. So once again, just using the calculator, be careful with your viewing window.